Hi there. If you follow me, you already know about Epigrass, but I wanted to make this video for a couple of reasons. First of all, I just did a 3.0 release of the software, and the second one is that I never did a proper video introduction about this software. So what is Epigrass anyway, for those of you who never heard about it? Epigrass is a software for georeferenced analysis and simulation of epidemics. Now this is in everybody's mind, but Epigrass has been around for a long time. So long indeed that it's even part of the Debian and Ubuntu distributions. Yes, you can apt-get install Epigrass, even though the version that is available through apt is not the latest one. So the latest one is release 3.0, as it says somewhere in here, but it's available over in GitHub, but is also available through Python package index, and you can pip install it. You can pip install it, that's for sure, but it takes a little bit of fiddling before you can get it to work, because it depends on some other packages that are not Python packages, so they need to be installed on your system beforehand. But this is all documented in the very nice documentation that is available on Read the Docs. There's a link for this documentation on the README in GitHub. You should be able to find it. So there's a whole chapter here somewhere about installation. Yeah, building and installing. So it shows you how to install Python, databases that Epigrass depend upon, and a number of other things. I'm not gonna be spending my time in this video talking about this. So let's go through how to use it. Why should I use, or why should you mainly use Epigrass? Epigrass is useful when you want to run a epidemic model. Those are the models that help you simulate the spread of diseases such as COVID-19, and you want to simulate this epidemics over a number of cities or localities. It could be neighborhoods within a city. It could be anything that is defined in a map. So that makes it much more organized, because you don't have to think about geography. You can just grab a map and have it define the cities where your models are going to be run upon. So if you ever thought about this for even a second, you know that if I want to run my model over, say, 300 cities, that's a lot of work, because I have to find out how many people live in each city, where they are, a number of other things, and then write code to automate all this. So what Epigrass is actually it does this automation for you. So you can just provide a couple of spreadsheets, such as the site data file, which contains the X and Y coordinates of the localities, and those could be taken straight out of your map file, such as the centroids of polygons in a shape file, for example. But also you find in the sites file the names that you want to attribute to the cities, their populations, in the numeric code that we call the geocode, which is an unique identifier that the program uses internally to refer to these locations. You can add more columns to the spreadsheet with other variables that you want to be available for the model at the city level, but that's up to you, and Epigrass will make them available to your model at simulation time. It's a lot to explain about how to properly use Epigrass, but I'm just gonna go over these two main files, and then I'm gonna show you the new web dashboard that is the high point of this last release. So the second file that you want to have is an edge data file. The edge data file helps you connect the cities, like in a graph or a network if you prefer. There's a source and a destination. Those are the names of the sites or locations that you have in your site files. You define the flows in each direction. their distance in some unit that's meaningful to you, the geocode of the source, the geocode of the destination. So you have one line in this spreadsheet for every edge on your network. And once you define these two spreadsheets and gave Epigrass the map where it can find those localities by geocode, then you're pretty much set, and then you just have to run your model and look at the results. You run your model from the command line because the goal of Epigrass is just to make it as simple as possible to run those models. So there's no point of having a complex user interface because you just give Epigrass these files. You give it another file, it's called an EPG file, which specifies other parameters from your model, and that's it. And it does the simulation, saves the simulation on a database, and you just have then to look at the results with the Epigrass dashboard. So this is the interesting part. Once you've done all the boring stuff, you get a very nice visualization of the results of your simulation over this web dashboard. This is running on your browser, and you can even host this somewhere if you want to share your model with somebody else. But for now, it's running on your computer. You don't need any further tool to use this other than your browser. So the first panel that you see right away is a map with the final state of your simulation, colored by the number of total cases on each of the sublocalities in this map that I provided for my simulations. I can look at the number of cases here for the top 15 at least, because it would be too many to show on this bar plot here. And you can, if you have a model, you can have multiple simulations stored in a database. So I can select a different one, and Epigrass dashboard will load that simulation and show that to me. Further down, you can see a representation of the connections between the localities in your map. Notice that, this graph, especially even for this model, which is a fairly small one, there's only 250, if I'm not mistaken, localities in that map. You still have, would end up with a very big network, which would be very unwieldy to draw on the screen, let alone understand what's going on. So instead, what Epigrass gives you is a graph of the neighborhood for each locality. So if I pick a locality here, like I did, I can see the locality that I selected on this red dot, and its first degree neighbors shown around it. I can pick another one here. It updates with the new stuff. Finally, of course, the whole point of Epigrass is to do dynamical simulation. So can we look at it in time? Yes, we can. So we have here, once you selected your locality, you can inspect and you can select one at a time as you wish. And you're going to be presented with the map and a time slider here, where I can slide the time forward and have the distribution of cases in space be updated for me. If I go all the way to the end, then it stabilizes, doesn't change anymore. But if I go back, I can get different situations as the simulation is evolving. And below the map, you can find time series of exposed, infectious, susceptible individuals, number of cases arriving over time at that location from other locations. It's a cumulative thing, so that's a lot, but it's being added up. The incidence over time, it's a number of new cases happening over time. And lastly, but not least, we have key information about the model on the side. That's not a complete specification of the model, but just the key aspects. For example, it tells me that the epidemic model that I'm running is an SEIR, so that I remember what the simulation is about. So I can have, like I told you guys, I can have as many simulations stored in my database. Now I have two, but I have the timestamp here from when they were calculated, and I'm able to inspect any number of simulations in a touch of the button. So that's basically it for the new features. It took me a little bit of time to get this up and running. I actually quite like the result. I hope to be able to push this forward, especially if people like it and ask me for new features. I'm happy to improve this, but for now on, I think I'm pretty happy with what is already available, and I hope it can be useful to you in your work if you work with modeling of epidemics. So that's a tool that you can use right now. Well, thank you for your interest in this. In time, I may have other videos detailing further aspects of Epigrass. Thank you for watching, and bye-bye.